Let's now talk about multidimensional arrays. The arrays we have worked with so far were one-dimensional arrays, and they had a single index to access different elements of them. But arrays can also have multiple indices, and those come in very handy when we want to represent tables of information. Specifically if they have rows and columns, then the type of arrays that we use are two-dimensional arrays. And in the examples today, I'll show you two-dimensional arrays. Typically, the first index of a two-dimensional array specifies the row number of the element. The second index specifies the column number. Now, multidimensional arrays can well have more than just two indices, but for the examples today, we'll stick with two-dimensional arrays. The same concepts apply or extend just like that to multidimensional arrays. So in the next figure, I'll show you a two-dimensional array named A. And let's change this over. And this two-dimensional array has three rows and 4 columns, and for that we call it a 3x4 array. Now, in general, if a two-dimensional array has m rows and n columns, we call that an m×n array. And here's an example. Here's a picture of that. This is a 3x4, two-dimensional 3x4 array because it has 3 rows and 4 columns. As you can see, the element in the 0th row, 0th column, is referred to as A0, 0. The two indices are placed in separate square brackets. The first index being the row index, the second index being the column index. Counting for both rows and columns, as you can see, starts from 0 and goes through column 1, column 2, column 3. And similarly, rows are also counted from 0 to 1 and 2, just like before. So if you look at this particular element over here, A with indices 1 and 2, A1, 2, that is the element in row number 1, column number 2. So we have array name, just like before, an index, the first index, representing being called the row index, representing the row number, and the new thing, the column index, representing column number. Generally, if you have an I and a j index to access the element in the ith row and the jth column, we represent that as, or we write that as A, I, J, I and J being indices. In math, if you've been using matrices, sometimes you may have seen elements of a matrix being denoted like this. That's kind of, in programming form, you can think of the same thing being represented like this. One mistake that you might make initially is put both indices into one pair of square brackets and separating the indices with a comma. That is definitely wrong. You have to put the indices into separate square brackets. And just like you can initialize one-dimensional arrays at the time you define them, you can also initialize two-dimensional arrays at the time you define them, and that looks something like this. So this is an integer array B with 2 rows and 2 columns, and here you see it being initialized at the time it is defined. We put each row, the elements of each row, into a separate pair of curly braces. So in this case over here, if I wanted to draw a picture of this array B, it would look something like this. So we have 2 rows, 2 columns. Then this initialization would mean that the first row contains 1, 2, and the second row contains 3, 4. That's what this would do. So the thing to remember is that each row of elements is grouped into the same, each elements of the same row are grouped into the same pair of braces. So in this particular example over here, this element would be B0, 0. This one would be B0, 1. This one would be referred to, can be accessed as B1, 0, and this one could be accessed as B1, 1. This being column 0, column 1, this being row 0, row 1. And just like there's this trick to initialize elements of a one-dimensional array to 0, we can do the same thing for two-dimensional arrays. So if we modify the initialization statement we saw on the previous slide to something like this, what this would do is this would still create a two-dimensional array of 2 rows and 2 columns, but it would initialize the values to something slightly different. See over here that in the first pair of curly braces we have only one number, which means this would be initialized to 1. The second element on the same row is not specified. This would automatically be initialized to 0. And on the second row we'd have 3 and 4 because they're specified over here. So any element not specified and after automatically is initialized to 0. And here's a very simple example that defines 3 arrays called array 1, array 2, and array 3. They all have the same dimension, 2 rows, 3 columns, all of them. But we use different ways to initialize them. So the first one in the main function, the first one is array 1, and this one's being initialized in a very straightforward way. We have 2 rows, 3 columns. So this one initializes elements in the first row to 1, 2, and 3, and elements in the second row to 4, 5, and 6. Then we have array 2. Let's see. Let's see what happens to that. So this will be initialized to, So this will be initialized to, so this is also same dimensions, 2 by 3. And you can see that over here we're not grouping elements by rows, but we only have a single pair of curly braces. In this case, what happens is this: elements are assigned to starting from the first row, then simply moving on to the second row, and then when we run out of elements after 5, the rest are initialized to 0. So we'll get something like this. And then for array 3, we're only specifying, we have 2 rows. And for the first one, we're specifying only 1 and 2. For the second row, we're only specifying 4. The remaining ones will all be initialized to 0. And then we have this print array function whose prototype is given up here. And there's something I want to say about that too. And after initializing each of these three functions, we just put out the statement values in array 1 by row R, and then we call this print array function. And what that'll do is it'll print out the elements in this case array 1. Second time we call this function with argument array 2, it'll print out the values in array 2, and third time the values in array 3. Now there's something different in the function prototype for print array. If you notice, we said when we were talking about, when you looked at when passing one-dimensional arrays, that we do not have to specify the size of the array in the argument, and that's still true for the row numbers, the first index. But when you have multi-dimensional arrays, you can skip the first index. You do not have to specify any number in there, but you have to specify the array size for all other indices that come after that. So in a two-dimensional array like this one, you have to specify the number of columns. There's a very good reason for that. This is the print array function, by the way. So you can see that the unknown row number and the specified column number, the fixed at 3, can also be seen over here in the function header, in the function definition. And the code inside the print array function is quite straightforward. We have two for loops nested one inside the other. The first one over here has counter I, the second one inside has counter j. So what's happening is we start a row number, right? I is being used as a row index. We iterate through the column numbers, j. So basically for an array with, like it said, 3 columns, what we do is we fix the row number, start at 0, and we go through the columns. And when we're done, this is what happens in the inner loop. When we get out of the inner loop, we go back to the outer loop, we change rows. And then we go through all the columns again. So this is the order of traversal by which we go through this two-dimensional arrays in this print array function when we use nested for loops like this. If the outer for loop is the row index and the inner for loop uses the column index as its counter variable, or loop control variable, I should say. When you run this code, you get these outputs over here. First one, it shows you the output, array 1 being initialized to 1, 2, 3, 4, 5, 6, 2 rows, 3 columns. Second one shows you the values initialized to 1, 2, 3, 4, 5, and the last one 0. And the third one, array 3, shows you 1, 2, 0, 4, 0, 0 as the initialized values of array 3. So everything I just talked about that I explained in the code directly, the next few slides talk about that. So I'm going to skip over that because it's a little hard to follow when you don't have the code in front of you, or at least side by side with the slide. I'll leave this in for documentation purposes. So, like I said, the first index of a multi-dimensional array is not required to be specified in a function that takes a multi-dimensional array as argument. But all subsequent indices must be specified. And the reason is that memory is basically, you can think of memory in your computer, RAM, as a one-dimensional array. Memory location have addresses, which think of them as being incremented by 1, going from one to the next. If you want to think of your data as a two-dimensional structure, like we did just now in a two-dimensional array, uh, there needs to be a little bit of math that needs to be done. So the way it happens is um, the first row of the array. So for example, we had array 1 with these values. The way this would be stored in memory is 1 would be stored in one element, then 2 in the next, 3 in the one after that. And after that, it'll store the elements in the second row, which is 4, 5, and 6. And if you had any more rows after that, those would come after that. But in your code, when you specify the indices to an element, so for example, you say array 1, 1, 2, for example, means you want to jump, you want to go to row number 1, column number 2, the element in that place. For that, you need to know how many elements are in a row. How many elements ahead should it jump? So when you say row number 1, means you have to skip over row number 0. And for that, you have to know how many elements are in row number 0. That happens to be 3. So you have to jump over 3 locations, and then you have to go to element number 2 in column number 2. For that, we have the first element after that will be for column number 0, column number 1, column number 2. So we're talking about this value over here, this element over here. In order to do this kind of math, in order to understand which location in memory to go to, in order to do that math, the compiler needs to know, or actually a function needs to know, how many columns your two-dimensional array is in size. You can also think of each row in your two-dimensional array as a one-dimensional array. And we'll see that work out and how that can change the code in the next example. So, like I said, the compiler must know how many elements there are in each row, so it can skip the proper number when it jumps to a certain row number of the array. And since once an array has been defined and its size, its dimensions have been set, and those will not change after that, when we go through entire arrays or parts of arrays, we usually know the number of times a loop will run along whatever dimension, which is why you'll frequently see the for loop being used in conjunction with operating on arrays. So, for example, imagine this piece of code. What is this doing? Well, it is operating on row number 2, on elements of row number 2, and the loop itself starts at 0, goes up to 3. So basically this is operating on if you have, we don't know how many rows we have over here, but you have row number 0, row number 1, row number 2. And what this will do is it will go from column number 0, 1, 2 to 3 through these 4 locations. And of course, initialize them to 0. So basically these 4 elements that you see over here will be set to 0. That's what this code is doing. take this for an example. You have some variable total, which is initialized or set to 0. It's not being defined over here, so not being initialized necessarily, but so total is being set to 0. And then we have two for loops, one inside the other. Looks familiar. The outer for loop, which is the one that comes first, has a counter variable called row, which goes from 0 to 2. And the inner for loop has a counter variable called column, which goes from 0 to 3. And inside the inner for loop, we're adding each element of array A into total, which was initialized to 0. So basically, we're adding up all the elements of array A. And from here, it seems that array A has 3 rows and 4 columns. Let's look at a slightly larger example that uses two-dimensional arrays. In this one, we're going to use a 3x4 array called student grades, and we'll be using for loops to iterate through this array. Each row in this example, so 3x4, each row represents a student. Each column represents a test score between 0 and 100. And what we're going to do in this simple program is we'll have this two-dimensional array, and we're going to compute we're going to find a couple of values from this array. Things like what the minimum grade was for any student that semester. Things like what was the maximum, the highest grade of any student in that semester. What was the average of a particular student. And also a function called print array that does something we have already seen, that outputs the two-dimensional array in a nice table format. So this might seem like a lot of code. It's actually very straightforward. So we have a main function. So we define a couple of symbolic constants: students 3, exams 4. And you'll see why this will be this is a good idea to use symbolic constants, because instead of having just some numbers appear in our code, 3, 4, by defining these numbers as symbolic constants, when we use them in code instead, it's easier to understand what's going on, what we're iterating through, for example. So we have in the beginning, right before the main function, in fact, we have a couple of function prototypes: minimum, maximum, average, and print array. Minimum, maximum, and print array, as you can see, take 3 arguments. Take an integer, a two-dimensional integer array, which they receive as grades, and after that, pupils and tests. So basically the number of students and the number of tests, the dimensions of this array. We also have another function called average. This one does something slightly different. This one seems to be taking a one-dimensional array, and along with it, the number of tests. So basically, this average function, remember, this average function is computing the average of each student in the semester. It is taking only one row of the two-dimensional array, only one row. So either this one, or this one, or this one, and computing the average of either for this student over here, the average of these four values, or for this student, the average of these four values, or for this student, the average of these four values. But in any case, this function is only taking one of these set of four values, or the index to the starting location of a student's scores, and it's treating it as a one-dimensional array, although the whole structure is a two-dimensional array. So in the main function, we define and initialize the student grades two-dimensional array. And it has 3 rows, 4 columns, of course. And those are the initialized scores. We begin by printing out the array itself using the print array function. Notice something else, that all of these functions that are taking either the whole two-dimensional grades, student grades array, or taking only a row of it, none of them has any need to modify, to change any of those values. And for that reason, when they take that part or the whole two-dimensional array as argument, they're receiving them as with a const keyword, meaning they're not allowed to make any changes to any of those values. So in the main function after that, we have another printf statement, which prints the lowest grade in the semester and the highest grade in the semester by any student. And finally, we have a for loop in which we go through all the students, and for each student, student 0, student 1, student 2, we print out that student's average score for the semester. And this is what the minimum function looks like. Very straightforward. As you'll see, the maximum function is almost identical to it with some small changes. So it defines an integer called low grade, which is initially set to 100. And then we have 2 for loops going through the entire grades, two-dimensional grades array. And whenever it finds a grade that is less than what is currently in low grade, it updates the value of low grade to that new found lowest grade up to that point. And we use an if condition for that. So if the grade that we're looking at in the array, if that is even lower than what's in low grade right now, it updates the value of low grade. And after it goes through the entire grades array, low grade will have the lowest grade in that two-dimensional array, which it then returns. That's why it has an integer return value. The maximum function is much the same way. It defines an integer high grade, which it initializes to 0. It also goes through the entire grades array. And if an array element is larger than high grade, it updates the value of high grade. And by the time you come out of the 2 for loops, high grade must contain the highest value inside the two-dimensional grades array, which it returns. That's why the maximum function also returns an integer. Then we have the average function, of course, and that defines an integer total, initializes it to 0. It adds all the test scores for a student using a single for loop, remember, and it goes up to value of tests. So tests in our case are 4. It goes from 0 to 3. There's a less than sign over here, so think of it like this. It adds all the test scores for a student into total and then divides total by the value of tests. And because the resulting answer can be a fractional number, it casts total as a double, then divides by tests, which will also be converted to double at runtime, and the return value will be the average, which will also be a double, which is why the average function's return type is also double. And finally, we have the print array function. This is very similar to the print array function we saw in the previous example. So it takes the whole array as argument along with number of rows, number of columns, prints out a nice looking column header. And then we have two nested for loops. And we print out whatever grade is there, we print it out as a 5-digit number, right aligned. And when you run this, you'll see this as the output. So remember, we called print array function first. That prints out the contents of the student grades array. Then we call the minimum function, the maximum function, and then we call the average function, which prints out the average of each student. So this is again description of much of what I already talked about. So like I said, the minimum function is in structure same as the maximum function. The local variable low grade is replaced by high grade going from minimum to maximum function. But I think the really interesting thing that here to show is in the average function, in which we pass one row of the two-dimensional array student grades. We pass that using a single index over here, and that index is basically a row index. You could do the same thing, by the way. Let me show you that. Instead of passing it like this, we could have passed it like this. The point is to pass the address in memory of the first element, the element of column 0 of that particular student. And you can do that treating it as a two-dimensional array, or you can, if you understand arrays by now, you can pass that same address like this by passing the starting address of that student's row number. So as an example, this is basically the same as student grades row number 1 element 0. Means the same thing. Or I should say, comes out to the same address.